Hello, and welcome to this episode of Madison's Chemistry. Today we're going to be talking about collision theory. So, the first point of collision theory is that 1. Atoms must collide in order for the reaction to occur. And I mean, this makes sense. If we have molecule A and molecule B, we know that in order to make AB, that our two molecules must collide. And we know that everything has to do with the likelihood that they will collide. So we know also that the rate of the reaction is directly proportional to the number of collisions. So if we increase the amount of times that A and B collide, we'll increase our amount of products. Okay, so then the next part is that our molecules must collide in the correct spatial orientation. Okay, so let's say we have molecule A and molecule B, and they need to collide head-on in order to make AB. And then we take these same two molecules, and now we have molecule A and maybe molecule B like this. Well, this could potentially, if they need to collide at this angle, this might not actually work, right? Like if it came up from behind, I guess this is kind of a bad way to draw it. Let's say they need to collide like this, and this one just kind of comes and attacks it from this end and just hits it from the back instead of from the side. Then it might not actually go to form AB because it doesn't have the proper spatial orientation. And this was a concept I didn't grasp until organic chemistry, but if you can see it from this side, I think this is a pretty good way to explain it. That if it comes up from the behind and it sneaks up on it, that it's not going to have the same response as if it's a straight-on collision like this. Okay, and then the third part of collision theory is that atoms must possess a minimum energy for the reaction to occur. Okay, so if we go ahead and look at the energy, and this is just the reaction pathway, and let's say that we're starting with reactants up here and products. Okay, so we need, if this is our activation energy, we'll need this much activation energy, say it's 50 kilojoules, to actually convert from reactants to products. And if we don't have these 50 kilojoules, so if this is missing, the reaction will not occur. And up here, we can call this the activated complex. So this is a few names. So one of them is the activated complex. Also known as the transition state. Okay, and that's going to be at the very top of our activation energy. It'll reach that transition state where it's in between reactants and products. Okay, and then the last step, or the last part of collision theory, is that if we increase temperature, we'll increase the number of collisions, which will therefore increase rate. And a big thing to highlight is that K, or our reaction constant, is dependent on T, or temperature. So if we have a reaction where we increase the temperature and it speeds up the rate, it's not because we're decreasing the activation energy. So if we increase temp, we're not decreasing EA, but we are altering this value, which is the rate constant. So it's important to know what's actually changing when we increase our temperature. It's K, it's not EA. So if you can get those all straight in your head, that'll really help you. And I hope this video kind of helps you have a better understanding of what's going on with collisions and collision theory. So if you found it helpful, go ahead and hit subscribe. That would be awesome, and give it a thumbs up for me. And if you subscribe, I will be posting videos every week according to Gen Chem 2 curriculum. So watch out for the next coming videos.